Hey, what's going on everybody? It's Caleb. In this video, we're going to talk about DynamoDB. Now, if you're coming from SQL databases, learning DynamoDB is going to be a little bit of a learning curve because everything is different. It's a NoSQL database, specifically a key value database. If none of that means anything to you, don't worry, we're going to go through all of it, but we're going to start off with what is DynamoDB, when you might want to use it or not use it, and then how to get started and how to organize your data. So to start off, here's the homepage for DynamoDB. It is a service under AWS, so you'll need to create an AWS account, but it does have a free tier if you just want to get started. The thing with DynamoDB is that it is extremely fast, and this is made possible with the design of DynamoDB. An additional benefit is that it's fully managed, and what that means is you don't have to worry about all the database management stuff. We don't have to worry about a dedicated database server, and this is known as serverless. So pretty much you just pay for how much you need, and the rest is taken care of for you. While you create an AWS account, I'm going to bore you with this information over here. You can read through all of these if you're interested, but the main thing I wanted to call out is this line. And this is under one of the reasons you might not want to use DynamoDB. If your service requires ad hoc query access, then DynamoDB is probably not for you. So we're starting off with a negative, but this actually helps you understand when you might want to use DynamoDB. So if you need to be able to query for anything, saying where some attribute equals some value, that's not easily done in DynamoDB. Instead, you need to think ahead of time of what you might be querying for, because you can query on the key or any indexes that you create. When you do this, these queries are going to be extremely fast. And this is because the way DynamoDB stores data is the key is actually hashed, which says where to store that information on disk. Pretty much, DynamoDB knows exactly where the information you're requesting is. So it's a trade-off. You get a little bit less on-the-fly flexibility, but you get extremely fast read and writes. Any query you might need, you can create using indexes, and we're going to talk about all of that. Another side benefit of this being a serverless database is that it easily supports scaling. So if your application gets a spike of traffic, the database can dynamically scale. So let's go ahead, stop wasting time and get started. Let's go to the console. From the console, you can search for DynamoDB, and from here, you can create a table. So we'll just give it a table name such as users, and now we can talk about this partition key and sort key. These are very important parts of DynamoDB. So the partition key, this is the primary key. This partition key is hashed and is used to retrieve your items from the table. In DynamoDB, the records or rows are known as items. So we're going to go with something, let's just say email, and choose a data type. Our options are binary, number, or string. Well, let's go with string. Next up, we have the sort key. So if you have a partition key that has repeating values, you could sort those using a sort key. We're not going to use a sort key right now. We might look into that a little bit later. But what I do want to do is go through here and look at some of these settings. So we'll just go with customize settings. And for the read write capacity settings, you can go to on demand if you just want it to just automatically charge you for whatever reads and writes happen. Or you can provision a certain amount of read-write capacity in advance. Which one you choose is up to you. For financial protection, I would suggest going with provisioned because that allows you to prevent it from just charging you a bunch of money. So getting started as you're learning, go ahead and turn auto scaling off and provision capacity units. I'll explain this in a minute, but 5 is a reasonable number to get started with. This is for the read section. There's also a write section, so I'll turn auto scaling off and leave provision capacity units to 5. These write capacity units and also the read capacity units determine how fast you can write and read to the database. A value of 5 here means you can read 5 items per second. Now it's not exactly this simple, because the size of the item matters as well. So if you have a small item under 1 kilobyte, it takes 1 write capacity unit to write that item. So you could write 5 items per second with 5 write capacity units. It works similar for read, except that small item size is 4 kilobytes. So a 4 kilobyte item would take one read capacity unit to retrieve that value from the database. This took me a while to wrap my brain around, but I eventually figured it out. So giving 5 to both these values using small items would allow us to read and write 5 items per second, which in our case is plenty. You could even lower it if you're just learning, but having a provision capacity of 5 is fairly cheap. As you're learning, you keep these numbers low, and then once you're ready to deploy, you can up the provision capacity units later, or switch to on-demand or auto-scaling. That looks good, so now we'll just skip the secondary indexes for now. Here's the estimated cost, $291 a month, no biggie, and we'll leave the encryption at rest to its default and create the table. Alright, so we just finished creating that table, and notice we didn't create any columns. The only column we had to worry about was the email, which is the partition key. In NoSQL, you don't worry about the columns ahead of time because there's no table structure. Instead, that's worried about when you insert data. So when you open this table, you can explore table items and see that there is 0 items in the table. What we can do is we can create an item, and using key value pairs, you can define this structure. You can do it in JSON, or you can do it in a form style. So you just define the email, which is the only thing required, and then you can add a new attribute choosing from these data types. Now generally your items are going to be pretty similar, but it does give us some flexibility if some items have additional attributes or some items have less attributes. So let's go ahead and create an item. We'll just add an attribute and we'll say string. This will be the name. We'll give it Caleb, and let me give it an email. caleb@email.com. Let's go ahead and add a few more attributes. Let's say we're making some kind of social media or something. Maybe you could have followers, and well, I don't know, we'll just go with like 5. Maybe another one, verified, and we'll just set this to true. And this looks good. So we'll go ahead and create this item to see how it works. And now when you visit this table, you should see that item here. And the columns now show up. Now to illustrate NoSQL, let's go ahead and create another item, but this time change those columns just a little bit. We will give it an email. We'll just say sally@email.com. Add a new attribute, say new value friends. And we'll set this value to like 100. And we'll also add in that name. So name, we'll just say Sally. Looks good. We'll create that item. And now the table structure is going to look a little bit different, as this is just a view of the data. Pretty much any user that didn't have followers is just going to be empty. Same thing with this verified or friends. So you can see how it's kind of missing some spots here, but it's doing its best to display the table as it should be. So when you want to visualize it as a table, just realize it doesn't necessarily mean that every item has a follower value. It just means that it noticed at least one of these items did, so it added that column to this table view. Now, generally, I don't think your data structure should just be all over the place. So do a little bit of forward thinking of how your data should look. You know, maybe these should be the same. And if you have 0 followers, it should actually have 0. Same with friends, 0. And everybody should have verified true or false. So just because it's a NoSQL database doesn't mean you have to be all over the place. So what we can do is we can edit these, edit item, and we can add in any attributes. So number, followers, we'll just put it at 0, and then a boolean verified, and we'll set that to false. Save changes. Now that filled in some of the data. Let's just go ahead and add the friends to this one down here. So we'll go up and edit item, add new attribute of number, and this is called friends. We'll set that to 0. Save changes. All right, so now our data is filled out a little bit more. Let's just go ahead and create one more item just so then we can take a look at querying. So we'll just go with john@email.com. Name here is John. Friends is, let's go with 4. Followers, we'll do like 10. And then lastly, we had a boolean, which was whether or not they were verified. And we'll just go with false. Create item. So now we have 3 items and they all have the same data structure. Now when it comes to querying, you can't just do very complex where clauses. Rather, you search by the partition key. So let's take a look what that looks like. You just go in here and you'll say query, email, partition key, just put in the value, Sally@email.com. hit run, and it finds that value very quickly. Now, there is the option for a scan, and you can say attribute name, friends, and this is a number equals to 100, and then we run, and it will still retrieve Sally. This shows that there is some querying capabilities and filtering capabilities, but this requires a table scan, which is a very expensive operation, especially when you get into thousands or millions of rows. You should be a little bit more forward thinking and think of what queries you might want and design those to be indexes. So if there's something you want to search for regularly, you can create an index for that value. So for this, we'll just go back to the users table and we'll go into indexes, create an index. This is going to be very similar to how we created a table, and you can think of an index as another table. The data will get copied over, allowing us to query by essentially a new partition key here. So we're creating the partition key for this new index table. So let's say this is name, and then a sort key, we can experiment with that. This will basically, if two people have the same name, it'll sort them by a certain value. Let's just go ahead and say this is number, and we'll sort them by followers. So the index name is going to be name-followers-index. You can think of this as the table name. All right, let's scroll down. You can see there's a capacity calculator you can use to get an estimated cost. The capacity, you can copy it from the base table or you can customize the settings. We'll just copy from the base table. I like those settings. Here is the estimated cost for these settings up here. And the attribute projections, if there's only certain attributes you need when you search by this index, you can be specific and include those. However, I'm just going to keep everything. So let's go ahead and create this index. It can take up to 5 minutes. So it'll say creating. We'll come back in a few minutes. Alrighty, that's finished. And now when we look at the table items and we select this dropdown, we have the table itself as well as an index. So we can select that index, and now we don't have to do a scan, but we can just do a typical query. Same thing here, index. And then for the partition key, it was the name. So we'll just put in something like Sally. We can ignore this here for the sort key. We'll just get everything back, hit run, and we get one item returned, which is Sally. Now, you do have the option of sorting here, but we only have one person with the name Sally. If we went ahead and created a few others, let's go ahead and create Sally D at email.com. And then name is Sally. And we'll do followers 500. That's all I'll put for this one. And let's go ahead and create one more. Sally S at email.com. The name, it will also be Sally. And followers will be 5. We'll create. And now I want to do one more item, but this one's going to be a little bit different. We're going to create an item. And it'll be Sally J at email.com. For the name, we'll also do Sally. But we're going to leave the follower count off of here. Create the item. All right, let's try this again. So we search for Sally, hit run, items returned 3. Notice that the Sally without the sort key, in this case, the follower count, is not listed. So that is an important thing to understand with the sort key here. It's not a required attribute. However, those without the value are not going to be returned. And you can see it's sorted from least to greatest. We could try sort descending, hit run, and now it's 50050. Now this partition key, you can think of all of these Sallys being located in the same location. Now, if we wanted to search for a specific thing, let's say equal to 500, that search range is much smaller and it's much more effective. Now, as for creating relationships across tables, you don't really do that. You can simulate it. So as an example, let's say we're building the social media app and you had the ability to create posts. Well, each post is going to be associated with a user. The email is something that should be unique. So you could basically add an attribute to each post of the poster's email. This would allow you to add an index on that attribute and find all the posts from a particular email. Let's just go through a quick example of this so you can see how that would work. And then basically in your application, you could grab all of the posts from a particular person. If you want, you can pause the video and try to do this yourself. But if not, we'll go ahead and create the table. We'll just call this posts. The partition key, I can't think of a good natural key off the top of my head, so we'll just go with post ID, and we'll make this a number. And similar thing, I'm going to customize these settings, go into provisioned, turn off auto scaling, and leave off auto scaling for write as well. And we can create a local index as well. Oh, this is actually an important thing to bring up. A local index versus a global index. The main difference is that local indexes will have the same partition key, but a different sort key, whereas the global index will allow you to query attributes outside the primary key. So this is what we're going to want, where the partition key is the email. So as you can see, we're going to have some repeating data. And there's probably a lot of good design suggestions out there for NoSQL. This is kind of just something I thought of, but this can work. The only downside, if someone switches their email, might have to require a lot of updates. So that might not be the best solution for this, but it should work. You could sort key maybe by timestamp. That would make sense if you want to filter for like a user profile. Let's go ahead and make email capital, and we'll just say timestamp, where this is a number, email timestamp index. We'll project all the attributes and create the index, and we'll scroll down and create table. All right, that table is done. We'll go into that, take a look at the indexes, and you'll see that there. Let's go ahead and create an item. So we'll just say the post ID is 1, email, caleb@email.com. And the timestamp is a number. I'm just grabbing this timestamp off the internet. Good enough. We'll paste that here. This is a representation of the current moment in time. It's basically a count of seconds from 1970. We'll go ahead and create that table. Let's go ahead. Oh, I forgot an important thing. We probably want to have what the post content is. So we'll go in, edit the item, and we'll just add a string here, content. And, I'm just posting online, feeling good today. Looks good. We'll go ahead and create another item from the same person. So the post ID can be 1. The string email is going to be the same email, caleb@email.com. Number was the timestamp. Paste the same number, but this time I'm going to change the number a little bit. So I'll put a different number here. And then I forget, what was it? Content? Feeling gross today. All right, those are my social media updates. Pretty intense. Oh, well, definitely don't want that to be a number. So let's recreate that. We'll go with string content, feeling gross today. Oh, sorry. Yep. We'll want that to be a 2, actually. So create the item. All right, there we go. So we have 2 posts from the same person. Let's go ahead and create an item from someone else. So this will be post ID 3. String email is someone else. Timestamp, the number. Paste that in there. And then content. Hey everyone. We'll go ahead and create that item. All right, so here you can see our table. We have a pretty good summary. So now we can get all the posts from a single person by going to the query, grabbing the email timestamp, searching for a particular email such as caleb@email.com. And you can do all this through code as well. We're not going to do that in this video, but maybe in a future video, hint, hint, be sure to subscribe. And then we'll just run, and it'll give us the 2 posts from Caleb, and it'll have some sort to them. And you can flip the sort with right here. Alright, so that is your introduction to DynamoDB. I'm sure there's a quadrillion different things we could talk about, but I just want to get you an introduction and get you thinking in the right approach to DynamoDB, where pretty much the queries you want to do, you'll probably want to think of those ahead of time, or add an index whenever you think of one, so that you can quickly query that data in constant time. Thank you for watching. If you enjoyed, be sure to subscribe and peace out. But before you go, I wanted to mention I am working on a back-end Bootcamp course. If you want to know more information like this and backend web development, be sure to check out the resources in the pinned comment and probably the description as well to get some early access to the notes and be notified when the course is released. Thank you for watching. Peace out.